All right, here are your notes on section 6.2. We're talking about mechanical energy, okay, which we went over a bit last year. So again, this should be mostly review this whole unit from stuff we did last year. Okay, so we're going to first look at our work energy theorem. Okay, so a change in kinetic energy is always the result of an object changing speeds, right? The only way that we can get this to change is to change this. Okay, the mass won't change, and then this is a constant, it's always 1/2. So according to Newton's second law, it takes a non-zero net force to cause an acceleration, right? Which would be a change in velocity. Okay, and so F net equals mass times acceleration. So the changes in kinetic energy are always the result of work done by a non-zero net force. So basically, to change our energy, we have to change our force. Oops. So the formula, change in kinetic energy is equal to F net, which is equal to mass times acceleration, times the cosine of the angle that you're doing that work, or the force at, times the distance that work goes. And so, for example, here, okay, because like we're always looking, the only force that's applied here like is this arrow going up, okay, and it is doing work opposite to the force of gravity, okay, or force of gravity parallel. Okay, these forces are balanced, so in this case the net force is equal to 0. Okay, and so that would have basically no change in kinetic energy, anything like that, and so they are balanced out. Okay, which means our object is moving at a constant speed. So I guess we have kinetic energy, it just is not changing kinetic energy. Okay, so the work done can only increase the gravitational potential energy, but not the kinetic energy. Okay, because to change the kinetic energy, we have to have more force than it takes to overcome the force of gravity parallel. Okay, but as the object is moving up, okay, you are increasing the gravitational potential energy. Okay, in this scenario here, the forces are not balanced. There's more force applied than the force due to gravity. So the net force is now a non-zero net force. So the object is accelerating. So we have a change in kinetic energy. Okay, again, we'd also have a change in potential energy. Anytime something is moving up, it is changing its potential energy. Okay, so the work energy theorem states that the work done on an isolated system, okay, and in all these cases we're going to be working with frictionless systems, okay, is equal to the sum of the changes in potential and kinetic energy for the system. So basically, work is equal to the change in kinetic energy plus the change in potential energy. Okay, the examples, again, are out of your textbook, so you can look on, this is on page 308 on how to do this problem. Basically, as something's moving up with a different force, it's changing its height, so it's going to increase its potential energy. It's also increasing its velocity, so it's changing its kinetic energy. So then from that, you can find out like change in kinetic, change in potential, and then the overall work done. Okay, some more calculations. So this is for mechanical energy. Mechanical energy is equal to the kinetic energy plus the potential energy. So mechanical energy of an object is the sum of its kinetic and potential energy. So a lot of these types of problems, okay, you have to look at what energy that object has at a certain time. And so like in this case, again, this is out of your textbook on page 309. This cannonball is fired, okay, at the peak of its trajectory. So up at the top here, that's when it's going to have its maximum potential energy. Okay, and then at the bottom here, that's when it's going to have, its maximum kinetic energy. And we're mainly just going to focus on its energy is if it went up and down. Like we'll have to use our projectile motion to find out what its speed is at different, like in the X and Y axis, and to solve for this one. Okay, and so we can find the mechanical energy because we know its speed and we know its height that it gets to, and so we can find its overall. At the same time, a lot of these problems that you're going to be doing on your worksheet, the mechanical energy is going to be balanced out. So basically, like if you get a example, like you throw something in the air, you throw a ball in the air and it wants to know like what is its maximum height or what is its maximum velocity. Those are usually the two kind of equation, or like the two things that you need to find. So you have to kind of look at like what is the total energy. So if you throw something in the air at the start, when you first throw it, it only has kinetic energy because it's not up in the air yet. Okay, and so its maximum kinetic energy would be the speed that you throw it up, and then times the mass times gravity, or sorry, times 1/2 times the mass and the speed squared. So mv squared is for kinetic energy. And then to find the maximum height, the max EK would equal the max EP. So as the ball starts going up into the air, your kinetic energy is turning into potential energy. And so at the peak, then your EK max equals your EP max. So you can make those form like basically EK equal to EP at that stage and solve for any of the unknown variables. Okay, for a lot of them, you don't need to know the mass because the mass will cancel out. Like if EK equals EP, then MV or 1/2 MV squared is equal to MGH. So if I'm looking for V, like I divide both sides by M, which cancels M out on both sides. So in a lot of cases, it won't give you the mass because you just don't need the mass. It doesn't matter on the mass. Okay, make sure you read these pages, okay, 306 to 309. Okay, that's where the examples are shown. Okay, if you have any questions, don't worry about the SNAP workbook. We don't even have that workbook. It's an old slide. Forgot to take that out. Okay, look over the check and reflect questions. Sometimes they'll help, and especially you're given the answers in the back of the book. So if you have a question on how to do it on your assignment, you can always look at the question out of your book, check on the answer, kind of work backwards to solve for it. Again, also I'll be hosting a Google Hangout, and we can go over anything that you need to.